there, Nareg is here. Today we're going to talk about how to study the variation of a radical function, or simply known by irrational functions. So radical function is when you have a function which is similar to this. For example, f of x is equal to square root of x, f of x is equal to minus square root of x plus 1, f of x is equal to square root of 3 minus x. So these are radical functions. We're gonna discuss about these functions, where we're gonna study about their variation, how these functions actually variate, and of course we're gonna draw the representative curves. The steps that we are supposed to follow are actually domain of definition, the limit, the derivative, and then you can simply choose some particular points and directly draw the curve. So let's start with the first example. So let's say we have f of x is equal to square root of x. Now, the domain of definition of this function, x should be greater or equal to 0. This is the main condition in order to have your function defined. So x should be should be greater or equal to 0. So you can say the domain of definition is from 0 to plus infinity. Now, regarding the value of 0, f of 0, it does exist, it's 0. We can study the limit for x whenever x tends towards plus infinity. So the limit when x tends towards plus infinity of your function, which is square root of x, is equal to square root of plus infinity. It's again automatically plus infinity. Now you can go to the derivative. So f of x is equal to square root of x. So f prime of x is equal to 1 over 2 square root of x. Now the domain of f prime, d of f prime, is from 0, but 0 excluded, to plus infinity. Now, what about the sign of f prime of x? Now, we have to check. The numerator is 1, it's positive. The denominator is 2 square root of x. Again, it's positive in the domain. So f prime of x is actually positive. For the table of variation, you will have x going from x going from 0 to plus infinity. So f prime of x is shaded in this part, and it's positive whenever x takes any value from 0 to plus infinity. F prime of x is positive, and your function f of x is actually an increasing function. An increasing function, of course, from 0, f of 0 is 0 to plus infinity. Now, the second step, actually the fourth step in this case, after doing the domain of definition, limit, derivative, the fourth step is to take a few particular points and then simply draw the curve. We already know that f of 0 is 0, f of 1 is equal to 1, f of 4 is equal to 2, f of 9 is equal to 3. So let's draw the curve. So we have alright. For 0 we have it 0. For 1 it's 1. For 4 it's 2. And for 9 it's 3. So your curve will have this shape. This is the shape of the curve that you will be having. So this is how you represent square root of x. I'm going to take another example, and of course we're going to draw a curve. So another example. F of x is equal to minus square root of x. Again, you will have to say that this function is defined when x is greater or equal to 0. So your domain of definition is from 0 to plus infinity. You will have to calculate the derivative, the limit when x tends towards plus infinity is of your function, of course, is equal to minus square root of plus infinity. So it will be minus times plus infinity. It's minus infinity. Derivative again f prime of x is equal to minus 1 over 2 square root of x. You just have to use the formula. I'm gonna just remind you, when f of x is equal to square root of x, your derivative f prime of x is equal to 1 over 2 square root of x. So you can use this formula. This was for f prime of x. Now, what about the sign of f prime of x? You have a numerator which is negative minus 1, and as for denominator it's positive, so the whole fraction will be negative. So the whole fraction will be negative. So I can simply say when x goes from 0, of course in this case 0 again, it's shaded because we cannot have 0 for the denominator. F prime of x can take negative values for any value of x between 0 and plus infinity, so it will be negative. Automatically f of x will be decreasing. So it's from 0 to minus infinity. Again, I take a few particular points. F of 0, it's 0. F of 1, it's minus square root of 1, it's minus 1. F of 4, it's minus square root of 4, it's minus 2. F of 9, it's minus square root of 9, it's minus 3. So let's draw the curve. So in this case we will have All right. Okay. So I'm gonna place these points. For 0 it's 0. For 1 it's -1. For 4 it's -2. And for 9, yes, it's -3. So these are the points, particular points, and this will be my curve. This is how you draw the curve of the function f of x is equal to minus square root of x, negative square root of x. I'm going to take a final example. When you have your function, let's say f of x is equal to square root of 3 minus 2x, let's say 3 minus 2x. Now in this case you will have to say that 3 minus 2x should be greater or equal to 0. This is how your function will be defined. So minus 2x is greater or equal to minus 3. X is smaller or equal to minus 3 over minus 2. So x smaller than 3 over 2. So the domain of definition, d of f, is from minus infinity to 3 over 2. Now, we can study the limit, of course. Limit when x tends towards minus infinity of our function of square root of 3 minus 2x. So it's square root of 3 minus 2 times minus infinity. So it's square root of 3 plus infinity, it's plus infinity. Alright, once you have calculated the limit, you can go and calculate the derivative. Now for the derivative, you will have to say that f of x, which is equal to square root of 3 minus 2x, so 3 minus 2x, it's simply in the form of f of x is the square root of a certain function u. So it means that f prime of x, derivative, it will be u prime over 2 square root of u. This is how you will be able to calculate f prime of x. U represents 3 minus 2x. So u prime will be minus 2. Okay, so from this function I can deduce that f prime of x will be u prime is minus 2 over 2 square root of u is 2 square root of 3 minus 2x. Of course, here you can say that your domain definition of f prime, d of f prime, it's not just like the previous case. It's no more from minus infinity to 3 over 2. It's from minus infinity to 3 over 2, but 3 over 2 excluded. Now what about the sign of this derivative? It's very simple. You will have to check your numerator. So your numerator is negative, the denominator is positive, so the whole fraction will be negative. So in order to make the table of variation, you can say when x takes any value from minus infinity to 3/2, f prime of x, of course it is shaded in this part, it will be negative. So f of x, it's decreasing. Of course, f of 3/2 is 0, and as for the limit when x tends towards minus infinity, just what we had already calculated, for minus infinity it's plus infinity. So our function decreases from plus infinity to 0. Finally, we will be able to take some particular points and then simply draw the curve. So our function is f of x, which is equal to square root of 3 minus 2x. Of course, you can say f of 0 is square root of 3, it's 1.7. F of 3/2 we already calculated. We can say let's take f of 4, let's say, is square root of 3 minus 8, so it's excuse me, I cannot take the value f of 4, it does not exist. So let's say f of 1, it's the square root of 3 minus 2 times 1, so it will be square root of 1, which is 1. F of minus 5, it will be equal to the square root of 13. F of minus, let's say, minus 4, it will be the square root of 11, and then you will be able to draw your curve. So in this case, you will have the values of x going from minus infinity to 3/2. So let's say this is 1 and this is 2. This will be 3/2. 3/2 is 0. For f of 1, it's 1. F of 0, it's 1.7. F of minus 4, let's say, so f of minus 4 is the square root of 11, so it's 3 point. it will be a certain value which is here. Alright, so I can simply draw my curve. The curve will have a shape like this. So from plus infinity it tends towards 0. So this will be the shape of my curve. So yeah, we took 3 examples of radical function, or simply if we can say irrational functions, and we studied the derivative, the variation, plus we were able to draw the representative curve. That's it for the radical function. So why not subscribe to my channel, so whenever I upload new videos, new materials, you will be able to notify, and you will be notified. And I can also share my Instagram and Facebook account in case you want to ask any question or simply leave a comment below. Thank you for watching, and I hope it was helpful. See you next time.